Welcome to introduction into engineering mathematics. That is, now we are dealing with the limits. So look at limits involving difference of two squares. We look at limits that involve trigs. We look at limits that involve constant, limits that with a root where we need to do the conjugate thing. So without wasting our time, let's get started. So the introduction. So when you hear the limits, this concept of limits is very simple. So pay attention. So when you are given y as a function of f of x like this, okay, so when you are given a function of this as x approaches some certain number a, okay, the limit of a function then can be written as limit as x approaches some certain number, then that function. Okay, so this is how it will be expressed. Yeah, so it will be expressed like this. So if we are expressing like this, let's have an example. Let's have an example. Okay, so let's say we are given now this function limit as x approaches, let's say as x approaches, let's say 1 of x squared minus 4 like that, then over x minus 2. So we want to see how this will be performing. So this is just the introduction, and we'll make sure that we picture it to you, and so that you get the clear information over limits. So limits are very simple so long as you know what is happening. So when you are given this, so a limit for it to exist, for a limit to exist, you need to prove on both sides. So we'll say for limit to exist, it must approaches some, so it must approach it should approach a fixed number, so that number should be similar. So for a limit to exist, it must approach a fixed number, so that number should be achieved. So for a limit to exist, it must approach a certain number. Let's say whenever we try from left side, it is trying by all means to reach 2. Whenever we are trying from the left side, it's trying by its own means to reach the same 2. So that's what we'll be doing. So without even wasting our time, let's see how this will be performing. So that's the very point to master, to say for a limit to exist, it must approaches a fixed number, so being from left or right. So now seeing that we have 1 here, this one here, so you put 1 here, you draw a number line. This is your 1, so meaning that this is 1 here, their numbers say 1 point something, this side their number 0 point something to 0 point something. So this is the line. So this side is the left side, right? This side is your right side. So we'll be trying to see. So let's test this one. Let's test. So in this case, if we say we insert x, then what will be our result? So the values now from left, let's see, the values from left will be putting here. So the values from left of 1, we can say we have, let's say, 0.8. So when we put 0.8 there, it will be 0.8 squared minus 4 over 0.8 minus 2, which will give us 2.8. Okay, so that's what we get. So we get 2.8 like that. So again, the other thing, we can test another one. Let's test another one. We can test another number there. We can test another number. So if we test 0.9, so we put 0.9 there, what will be our f of x? What will be the result? Then remember we're doing it from the left. We're doing it from the left. That's why we are putting this is 1, our interest is 1. So want to see on a number line this side and also this side, will it approach a certain number which is just fixed? Then we'll say the limit exists. So now let's go. Let's try 0.9. So if put 0.9 there, squared minus 4 over x, that is of course 0.9 minus 2, like that. So this one will give you, if you do that, it will give you 2.9. So this is 2.9, like that. So meaning here is 2.9. Let's try another number. Let's say, okay, these are enough. We can be trying a lot of number, but these are enough. So as you can see, if we round off these two, it will give us something like 3. If we round off again these two, it will give us something like 3. Have you seen? So that is from the left. Now I want to try from the light. So we want to try from the light. So let's try from the light. If it will be trying to, by all means, to reach the same 3. So let's do it. Now that from the light we can have 1 point something, because this is 1, we are going this side, so that's 1 point something, 1 point something. Let's try 1.1. So if we put 1.1 there, if we put 1.1, what will be our result? So we are saying we are putting 1.1, so that's 1.1 squared minus 4 over 1.1 minus 2. So this will give us what? If we do the calculation, we're using a calculator there if you have a calculator, but you're not allowed to use calculator in engineering mathematics. So 210. So now if we put 1.1, you are going to realize that you have 3.1 like that. Okay, so put 3.1 like that. So what other number can we try? Let's try 1.05 and put there. We see what will happen. So let's do that. So that is if we say 1.05 squared minus 4 over the same 1.05 minus 2, this will give us what? It will give us 3.05 like that. So meaning that this is 3.05 like that. So have you seen this number? It can be rounded off. It can't be rounded. You can't round it to 3. So this one, I mean to 4. So this one will remain 3. This one will remain 3. So this limit from the right and left, it's trying to approach a fixed number, and that is what? 3. So when you have this as your conclusion, as you are working this, then you say the limit does exist. So the limit exists. So because it is trying by all means to follow a fixed number, that's why we are saying the limit exists. So there is other way of doing it. So we are saying our final answer is now 3. So we can do it by this. So there is the other way you can solve, but when you are told to show, you should do all these steps. Yeah, depending on your lecturer, but you should do this. So there's other way of doing it. See, this one can be solved as different of 2 squares. Let's try to simplify. So say limit as x approaches 1. So that's different of 2 squares if you can see on top. So say x minus 2, you know, difference of 2 square. Then that's x plus 2. This is the same thing here, what I've written. I've just simplified like that. So then we say x minus 2. Have you seen now that something is common here? So we'll cancel these. So we'll say limit as x approaches 1. Then you have x plus 2. So what you do is, the moment you insert this value into this, then you move this word limit. So we'll say now, 1 plus 2, of which it will give us what? 3. And for sure, this is what we have been trying to, what's this, to associate. This number is the one we were approaching as we were trying from the left and right. So meaning that the limit exists. So sometimes it's just clear when it gives you, then the limit exists. So that's how you do these things. So let's see another example. Okay, so the other thing that we can try, let's try something that is not possible to achieve. Let's try. So let's say the function is f of x is equal to x squared plus 4. Now there's plus 4 here, of which you can simplify to 2 different of 2 squared. So we'll try to see whether from the left and right. So find limit as x approaches 2. Okay, as x approaches 2, then yeah, the same question. So x squared, by the way, that's squared, so x squared plus 4 over x minus 2, like that. So let's try to see whether the limit will exist in this form. So yeah, let's do it. So now we start. This is the number of our interest. So we'll say this is 2, right? So it's 2. So if 2 on a number line like that, this side there are numbers such as 2 point something, this side there are numbers such as 1 point something. So we'll be trying those numbers. This is from the left, right? This is from the right. Are we good there? So this is what we'll be doing now. We'll be trying this number, this side and also this side, whether they will be approaching a certain number. So let's start from the left. So from the left we'll say x, so from the left we'll say x, then here we'll be putting our result. So if we put, what number can we put? Let's say 1.9. 1.8 is enough. So if we put 1.8, what will be our f of x? So we'll say this thing. So we'll say 1.8 squared plus 4 over the same thing, 1.8, then minus 2, like that. So if you use a calculator properly, by the way, just verifying. So this will give you negative 36.2, like that. So this is what will give you. So it will give you negative 36.2, like that. So let's try another number. Just from the left. Let's try another number. So what number can we put? Let's put 1.9. So 1.9. If we put 1.9, say 1.9 there squared plus 4 over 1.9 minus 2. So if you punch properly on a calculator, this will give you negative 76.1. So this is what we saw, negative 76.1. Let's try another number if possible. What number can you try? 1.99. Oh, this is just enough. Okay, it's fine. So we'll say let's try 1.99. Let's see. So if we put 1.99 there, it will be, so let's put 1.99. So if we put 1.99 there, so it will be 1.99 squared plus 4 over 1.99 minus 2. So this will give you what? This will give you negative 796. So this will give you negative 796. So this is negative 796, like that. So this is what you'll be getting from your left. So let's see now from our right. So have you seen this number? You can't say it's approaching any number. By the way, there are some failures which are showing here. So we can't conclude as for now. Let's try from the right. So from the right to have numbers, let's say x there, x there, then f of x there. Okay, I'll be doing it from here. So if we have that, let's start with the 2.1. Let's say 2.1 where x, we set 2.1 as x approaches 2. So if you put 2.1 there in this function, so we say 2.1 squared plus 4 over 2.1 minus 2. So this will give you what? This will give you 84. So 84. So this is giving 84 like that. So that's what we'll be getting from the left if you try 2.1. So this is from the right, I mean. So from the right, we are getting numbers above 2. Then from the left, we are getting the numbers below 2. So that is it. Let's try another number. Let's try 2.05 like that. So if you put 2.05, so it will be 2.05 squared plus 4 over 2.05 minus 2. So this will give you something like 164. So 164 if I'm not mistaken. So it will give you 164. So you put here 164. Okay, this number is just, you know, increasing. So let me end here and I'll give conclusion. Okay, sure. So let me just end there. Let me just end there. Sure. So I end there. Okay. So we said this is 164 like that. So this is our value. So now that we have this value, so let's conclude now. Are you telling me that as x approaches 2, is it trying this function, is it trying is it trying to approach a certain fixed number? The answer is no. Why? So if it is not trying to approach a certain fixed number, then we say the limit does not exist. So even by solving, you can't say the limit exists. So as you can see, it doesn't try to approach a certain fixed number. So you can't say the limit exists. So the limit in this case does not exist. So that's how it is. Yeah, that's how it is. So that's how it is. So that's about limits. So that's in general. We have just tried to picture. Now let's go into details and see more questions. So this one you can't even simplify. So what you do, since you can't simplify, what you do is you just say, okay, let's try to solve it. So I'm saying x squared plus 4 over x minus 2 like that, limit as x approaches 2, right? So that is it. So now as x approaches 2 like this, we try from the left, or just the same thing. Since we are solving now, we are not proving. So since we are solving, we'll say we insert 2 wherever there is x. So we'll put 2 there squared plus 4 over 2 minus 2. You know, a number, what is the value of a number? So that is 8 on top, then 0. What is the number? It is discarded. We can't have a situation whereby 0 should be, I mean the denominator should be 0. So this is just undefined. That's why the limit does not exist. So these are supporting answers, that I mean conclusion that you can make. The limit does not exist. So let's go into examples and see other just questions that we can do. Let's see. Let's see. So for example, what if now we have been given to solve to say find the limit in this case? So I want to see how we can find the limit now of a constant, the limit of a constant. So if you are given a function like this, you are given a function to say limit as, let's say, x approaches some certain number of a constant. So your answer should be the same constant. Let's say I give you to say limit as x approaches, let's say 6, then I give you 8 here, then find the value or evaluate. So you just give the same 8, you are done. So that is it. Let's say we are given to say example 2. So let's say we are given limit 9 of 9 as x approaches 7. What will be the value? So this should just give you the same 9. Okay, good. So what if now we are given to say limit of x as x approaches 7, like that? So what you do for this case, you insert this 7 to x, and the moment you insert, leave this word limit. So we'll say 7, of which is just 7, and we are done. Okay, so what if now we're given this? So that's about the constant thing. So for a constant, it's not difficult. Just bring the same thing and to be okay with you. So that is it. So what if you are given this as limit of 5x squared as x approaches a certain number negative 3, like that? So for this one, you just insert direct. The moment you insert, leave this squared, like I said. So you say 5 open bracket, you insert negative 3 there, is squared. So this will be 5. That's what's negative 3 squared, that's 9. So 9 times that is 45, right? So that's the answer. That's the answer. So what if now we are given this question to say we are given to say find the limit as x approaches, let's say, let me give you this one, lim 2x squared minus 3x plus 4 over, no, we don't put over here, let me just do this, as x approaches 5. So what you do for this one is just direct. So this is just direct. When you see, you know, a cubic function, a quadratic, this is a quadratic, by the way. So you, the moment you insert, you forget about them. So I'll insert in the next step. So I'll say 2 open bracket 5 squared minus 3 open bracket 5 plus 4, like that. So this will give us, that's 25 times 2, that's 50, right? 50. This is negative 15 plus 4, like that. So if you do that, that will give you 50 minus 11, like that. So what is 50 minus 11? What is 50 minus 11? So say that's 9. That's 39. Yeah, 39. So this is your answer. So very simple. Limits are very simple, provided you know what is supposed to be done. So we are trying to reach all the angles. So we have dealt with this situation. Also this situation, we have dealt it. Then what next? Let's try another example. What if we are given to say find the limit of this, let's say limit as x approaches 2 of squared minus 4 over x minus 2, like that. So this is the same thing, we have done it. We said it now, lim, then x as it approaches 2, then open bracket like that, then you do what, you say difference of 2 squares, so it will be x minus 2 close x plus 2 close like that over x minus 2 like that, you close. So these will go, so this will be limit as x approaches to x plus 2. So you just insert now and forget the word limit, so we'll say 2 plus 2, which will give us 4. So this is the value. Okay, so that's the value. So let's go now, and you know, they are very simple, provided you just master what is supposed to be mastered and leave what is supposed to be left out. So yeah, that's about limits. So now let's do the one with just a cubic function as well. Let's say limit as x approaches negative 2 of, let's say, 2x cubed plus 4 plus 4x squared minus 8x plus 1. So for, you know, for linear thing, I mean not linear, quadratic, so long as there is no denominator, for quadratic cubic functions, you just insert that value. The moment you insert it, forget about the area. So the next step, I won't even do anything, I'm not simplifying anywhere, so I'll just insert this negative 2. It's negative 2, so I'll say 2 open bracket negative 2 the power 3 plus 4 open bracket negative 2 the power 2 minus 8 open bracket minus 2 like that. Inside wherever there's x, we insert this value x given, so plus 1 like that. So the next thing that we will do is we simplify there. So that, what is the negative 2 square? That's 8, so we just say it's negative 8 because the 8 is an odd, 3 is an odd number, so say negative 8 like that, then plus 4 open bracket, this is the 4, then minus 8 like that. No, let me just do it here, let me just do it. So this will be positive, because negative times that, that's positive 16, so plus 1 like that. So this is what, negative 16 again, this is the plus 16 again, then plus 16 plus 1, so this is 16 by the way. So that is it. So this 16 and this 16 goes, so this will give us 17 like that. We are done. So that's about concept of limits. That's concept of the limits. Yeah, so that is it. Okay, so let's go to a question that give me mfuna mais broke. Okay, so now let's see the one which will involve roots, something like that. Yes, we are told to say find the limits of the following. Find the limit of the following. Limit as x approaches 0 of x plus 2 minus root 2 over x like that. So for this one, the way you work out this one, you do this, you conjugate this one. In short, you multiply by its conjugate, so that you can, because you can't just insert this one, you want to disturb this value which is down there. That's the value that you want to disturb. So what you do, your goal is to change this sign. So whenever you see a sign, it can be over, denominator, so in this case in numerator, so we'll multiply that. So say limit as x approaches 0 root of x plus 2 minus root x, like that, over what? X. So I'll multiply by its conjugate. The same conjugate is now, I'll just change the conjugate. To conjugate is to change the sign. So I'll say x plus 2 plus root x, like that. So the same thing, it's just a plan whereby I haven't changed anything. So x plus 2 plus x, like that. So I've just changed the sign. Otherwise, if I cancel, this is just 1. I've not changed anything. I've just tried to attach something because I have a goal where I want to reach. So now this and this will multiply, then this and that will be different of 2 square there inside. So this will be root x plus 2 inside, like that, different of 2 square. Okay, different of 2 square. Then you say you just get this because that's more like a different of 2 square, and you get this one with a negative. So minus again root x squared, like that, then over this will be x root x plus 2, that's root x plus 2, then plus root x again, like that. So that is it. So now if we were to simplify, so we are saying limit as x approaches 0. So now if we were to simplify this, it will give us this and this squared. You are cancelling the root, so that will remain with the limit as x approaches 0. So that will be x plus 2, like that, then minus what is root of what's squared root, so that will still give you, are cancelling that root, so it will give you x, like that. Then over we have x, like that, open bracket, have root of x plus 2, then plus root x, like that. So if you do that, you are going to have limit as x approaches 0. Then you insert now the values. Oh, you can insert at this point. So let me just remove this word limit. So I'll insert the value. So I'll just insert. The moment I insert the value, then remove the word limit. So I'll put 0 wherever there's x. Okay, I'll put 0 wherever there's x. So I'll put 0, but I won't cancel this because I've seen something. So I'll put 0. No, before even put 0, yeah, let me simplify this one. I need to simplify this one. So we'll say let's put 0. So if we put 0 there, it will be 0 plus 2 minus 0, just like that. So this will give us what is this? This is x, right? At 0 now. Okay, so if before even do that, because it might give us 0 down there, it can give us 0. So what we do is let's do this. Let's work out first what is inside. So we'll say what is inside. If we put 0 there, so it will be 0 0, what is 0? 0 minus that. Okay, so that is when you put 0, it will give you root 2, then plus 0, like that, right? Yeah, that is it. But before that, you don't cancel x. I was supposed to do something here. And I've just made a mistake. So what you do is, since I've run out of space, you multiply this one. Okay, it will cancel like that. So once it cancels like that, I've made a very big mistake. Let me just repeat it so that we get clear. Let me just repeat it. At this point, I need to repeat it. So this is the thing. I forgot. I had to put x here. It's 2 there, right? is 2 inside. That's why I've made a very big mistake. So now if it is 2 like that, you multiply like that, then you get difference of 2 square. So that's 2 what is inside there. So you get the difference of 2 square. Let me put it 2 like that. So that's root 2, and also that's root 2 like that. There's denominator there, there's denominator like that. So what you do is now this and this, it will give you different of square. There's negative and positive, just like we have a minus b. So this can be a plus b, and this thing is same as a squared minus b squared. So this is what we get for the one for negatives. So we get this one. So say root x plus 2, you know, we square like that, then minus 2 again like that, we square like that, okay, then over x like that. You know, there's lim as x approaches 0 of our function. Then here this one you multiply times that, so it will give you root x plus 2 plus root 2 like that. Not this what deleted, so it's 2 there. So from there, then what we'll do is we can simplify there inside. So it will be limit as x approaches 0. So when you put there the value you insert now. This we can simplify further by saying you square this, square will cancel this root, because we know that a square is half, and there is times 2 which will cancel there, and will still remain just nothing. So we'll say that is x plus 2 minus that's 2 again, that's 2, I've made a mistake. So that's 2, okay, minus 2 in the root, you cancel the root, so to give you 2 over, okay, so that will be x open bracket root x plus 2 plus root 2 like that inside. So what you do is now you forget the issue of limit. This way the limit, the moment you insert a value, you forget. So this is 0 like, by the way. So have x over x root of x plus 2, then plus root 2 like that, right? So this is what will remain with, right? Sure. So now from there we'll say by the way, let me come this side. So this and this will cancel, so remain with 1 over this is 0. We can now put the value of x after you forgot this one. So you put the value of x now. By the way, this is where you are supposed to put the value of x. I've already made a very big mistake there. So let me do it for you. Okay. So what you do is you now, this will cancel, so that will be 0, and you remain with the x over x open bracket root x plus 2, then plus root 2 like that. So this will give you 1, right? So you have 1 over root x plus 2, then plus root 2 like that inside. So that's root 2 inside that you are going to have. So by the way, this way the limit is still there. So I'll say limit as x approaches 0, 1 over root x plus 2 plus root 2. So now you forget this word limit and insert the value of x. So we just put where x is, and that's where 0 plus 2 plus root 2. So that will give you 1 over this plus that is root 2. So root 2 plus root 2, which will give you 1 over, you add these two, they are all in the root, so you say 2 root 2. So that's the value. So your answer is 1 over 2 root 2 like that. So that's your value. Otherwise, thank you very much for watching the video, and we can also talk about You can also talk about the issue of trig function. So if we have trig function, how do we find the limits? So there are two identities that you need to be aware. So those identities, they are very important in your engineering mathematics, that's calculus. So yeah, so once you are given, let's say you need to know some certain identity, so limit sine x as x approaches 0 over x of this, so this will always give you 1. Very important. What about the other one? The other one is is 1 minus, no, not 1 minus, so that's cos x minus 1 over x as limit x approaches 0. That will give you 0. So forget about this. So now in this case, let's talk about this. Okay, that is it. And also say this is very important. Thank you for watching the video. See you in the next video as we'll be solving the tutorial sheet. Thank you.